Hello, 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 and welcome back to more of the 2001 Euclid paper. That's the grade 12 contest put out by the University of Waterloo, CEMC department. And we're up to question number 5, which has a final solution A part and a written style B part. Let's see what we have here. Hopefully you've had a chance to take a look at these questions and try them for yourselves, because that's really the best way to get better. So, question A. Determine all integer values of x such that x squared minus 3 times x squared plus 5 is less than 0. Okay. So it's got to be negative. If you're less than 0, you're negative. Well, the easiest way to do this is to sort of treat these two things separately. Find out when is x squared minus 3 negative, and when is x squared plus 5, when is it negative or positive? Right? So, if we just take a look here to make a negative number, and we have two factors, then either A is less than B, A is less than 0 and B is greater than 0, so A is negative and B is positive, or A is positive and B is negative. So we have to have one of these two situations. Something to remember, when you're multiplying, a negative number times a negative number is a positive number. A negative number times a positive number is negative. A positive times a negative is negative, and a positive number times a positive number is positive. So this only happens with multiplication. When we're doing addition, if you take a positive number plus a negative number, you can't say what's going on there. Positive plus positive, yeah, you can say something there, it's going to be positive. Negative plus negative, sure, that's negative. But when we do a negative plus a positive, we have no idea. It's only with multiplication that we know all the situations. Positive, positive is positive. Positive, negative, negative. Negative times positive is negative, and negative times negative is positive. So these are some things that some people can get quite confused about. Hopefully, if you're writing this in grade 12, you have mastered these concepts. But, these videos aren't just for the people in grade 12 preparing. This is for everyone. And so this is a concept that can be quite tricky for some people. I know that my father, who's a math teacher, always sort of tries to explain it like this. Imagine yourself in an old sort of western town, and if you have a really bad negative guy, and you take him out of town, so you got a negative and you're taking him out, that's a good thing. So a negative plus a negative, or negative times a negative thing became positive. If you got a really good upstanding sheriff type and you remove him from town, so you have a positive multiplied by a negative thing happening, well, that's bad. You lost your nice sheriff. And if you got a really happy-go-lucky sort of banker type, that's a good thing. And if he comes to town, you're sort of adding him to town, that's positive. So a positive thing with a positive person, that is overall positive. And if you have a really mean, rough type, negative guy, and you have him come into town, that's positive. It's a negative times a positive, that's overall a bad thing. You have a bad, rough type coming to town, that's not good. That's negative overall. So that's the way he explains it. I think it's a little weird because I think, you're adding someone to town or you're removing him from town. That's not multiplication. That should be addition and subtraction. But if that little rambling did clear things up for you, fantastic. He swears by it. He teaches people that way. Overall, I just, do a bunch of practice problems with multiplying negative and positive numbers. You do 100 of them, you're gonna figure it out eventually. You're just gonna rote memorize it, frankly. Anyway, so to take a look at this question, we have x squared minus 3 times x squared plus 5. So we have two factors right there. We want an overall negative result. So we want either the first one to be negative and the second one to be positive, or the first one to be positive and the second one to be negative. So if we take a look at each of them individually, and figure out, where's the first one negative and where's the first one positive, we'll be able to figure out ranges of integer values of x. And we were asked for integer values of x. Ranges where the outcome itself is overall negative. So when is this positive and when is this negative? So x squared minus 3. Well, when is that negative? Well, we can add 3 to both sides. So we have to ask ourselves, when is x squared less than 3? Well, a square is always greater than or equal to 3. So 0 greater than or equal to 3. Or sorry, a square is always greater than or equal to 0. Take any integer, square it, you're going to get a non-negative result. So really, x squared's got to be 0 or 1. So x is either negative 1, 0, or 1. If x is negative 1, 0, or 1, then x squared minus 3 is going to be negative. How about when is it positive? Because maybe we want the first one to be positive. So we're greater than 0 when x squared is greater than 3. And that really works for any other square. So x squared could be 4, or 9, or 16, or really anything else. So x could be 2, or negative 2, or 3, and negative 3. Really, all we want is x isn't those other cases. So x is not negative 1, 0, or 1. Any other integer will do fine and will be positive. Okay. So that was our first factor. How about our second factor, x squared plus 5? When is that negative? Well, if we rearrange, we can subtract 5 on both sides, and it doesn't change the inequality. So we need x squared to be less than negative 5. But squares are never negative, especially integer squares. So this never happens. So for no integer values of x, will the second factor be negative? Will x squared plus 5 be negative? And actually we can check. This is always positive. Right? Because if you've got a square, you're definitely greater than or equal to 0, and if you add 5 to both sides, so you're definitely positive. And so that's just a little bit of side work there. Okay, so the second factor is always going to be positive. So x squared minus 3 times x squared plus 5 is negative only when x squared minus 3 is negative and x squared plus 5 is positive, because that's always going to be positive. Okay, so where did we say x squared minus 3 is negative? Well, exactly when x is negative 1, 0, or 1. And I think we were just asked to list out the values of x. Yeah, determine all integer values of x that make this work. And if we wanted to, we could do a little double check and plug in some values like 1, x equals 1 in here, and see that if we have 1, we'll get minus 2 times 6, we'll get minus 12. Yeah, that's negative. We could plug in some values that aren't on our list, like 4. And we'll get 13 times 19. Well, that's definitely going to be positive. So it looks like it all worked out. So that does it for part A. Now let's take a look at part B. At present, the sum of the ages of a husband and wife, which we're calling P, is 6 times the sum of the ages of their children, C. So P is equal to 6 times C. 2 years ago, the sum of the ages of the husband and wife was 10 times the sum of the ages of the children. 6 years from now, it will be 3 times the sum of the ages of the same children. So they're not going to get any more kids. And in the past, they had the same number of kids, so obviously all the kids are at least 2. Determine the number of children. Okay. So they're asking us for the number of children, so it might be a good idea to start off with declaring our variable. So get ourselves a brand new page. And we'll say, because we already used C in the problem, let n equal the number of children. Okay. So we're told that P is equal to 6C. And C is the sum of the ages of the children. P is the sum of the ages of the parents, with the husband and wife here. So let's just break it down. 2 years ago, each of the n children was or were? Each of the n children were, now was because it's past tense. I don't know, somebody does English competitions. Was or were? Each of the n children was 2 years younger. So overall, n, which is the number of children, times 2 years, so n times 2, or 2n, is the number of years that sort of difference between C and the sum of their ages in the past. Both parents were also two years younger. A difference of 2 parents times 2 years, 4. So we're told that P minus 4, which was what the parents' age was 2 years ago, the sum of their ages, is 10 times C minus 2n. Each of the children is 2 years younger, and that affects the total of their ages. So similarly, in 6 years, each kid has grown up, each of the n kids has grown up by 6 years. And each of the 2 parents has grown up by 6 years. So that tells us that P plus 12 is equal to, and we had C plus 6n. I just cannot remember the factor here, so we're going to go back and look at the question. 3 times the sum. 3. Okay. So now we have 3 equations here. P is equal to 6C. P minus 4 is 10C minus 2n. And P plus 12 is 3C plus 6n. So let's write these out, and we'll write them out in a nicer color. So P is equal to 6C. And then we'll bring the 4 over to the other side. So 10C minus 20n plus 4. And P, we'll bring the 12 over to the other side, so 3C plus 18n minus 12. Okay? So now we have 3 equations and 3 unknowns, we should hopefully be able to solve at least for n, but probably also for c and p. So now let's take that first equation and substitute it into the second one. So 6c is 10c minus 20n plus 4. So let's bring the 20n to the other side and the 6c to the other side. We'll get 4c plus 4 here. We can divide both sides by 4. 5n is c plus 1. Okay, and we could even say n is c plus 1 over 5. Now let's solve in terms of c. So c is 5n minus 1. Okay. Well, now we can take this, substitute it in the third equation, and we can also substitute in 6c for p into the third equation. So 3c plus 18n minus 12. Let's just double check that I had those right. Got to flip back a page. 3c plus 18n minus 12. Okay, we'll rearrange and then we'll be able to substitute in our value of c. So we get 3c on this side, we get 18n minus 12. Let's sub in 5n minus 1. N minus 12. So here we have 15n minus 3 is 18n minus 12. We'll bring the 3 over to the other side, so we'll get a minus 9 here. And the 15, we'll keep that over to the other side and bring 18n over here. So 15 minus 18 is negative 3n. And is negative 9 over negative 3. So n is 3. There's 3 children. And incidentally, this means that there are, so the sum of the ages of the children now is 14, and so the sum of the parents' age is 6 times 14, which is 84. And I'm sure if we went through and double-checked, all these equations would turn out to be correct. So p minus 4, so 80 is 14 minus 2 times 3, so 14 minus 6 is 8, so 8 times 10. So that one certainly works out. So, therefore, there are n equals 3 children. Children, not children. Sometimes when I'm doing these problems, just the spelling mistake just sticks with me the whole time. It drives me bonkers. Okay. So, let's see. We were only asked to determine the age of the children, and we did it, and we explained how we did it. We set up 3 different equations, and we had 3 unknowns. We had n, the number of children, the thing we wanted, the variable p, which they gave us, and the variable c, which they gave us. 3 equations, 3 unknowns. We should be able to work it out, and we did. We got n equals 3, and that's a very reasonable answer. Oftentimes, a question like this, somebody took their age and their husband's age, added them together, and the children's age, and made a problem up. So this is actually probably reflective of one of the contest creators' actual life and their children and their family. So the numbers do make sense. Parents adding up to 84, so each of them were sort of early 40s, or one was mid-40s, one was mid-30s, and they had some very young children. So, yeah, it makes perfect sense. And 3 children is also a very nice real-world answer. So, good question B, and we sort of showed what we were doing at each step of the way. And that wasn't a bad A question either. It's good overall, good question 5. I'm liking the Euclid so far. If you are, feel free to throw a like on the video, and stay tuned for question number 6, which we're going to do in the next video. So I'll see you guys then.